Welcome to this episode of the Engineering Project Management Podcast. Now, this is a podcast that's dedicated to helping project managers to sharpen their project management skills. I'm going to be your host. My name is Matt Douglas, and in this episode of the Engineering Project Management Podcast, I'm going to be speaking with Keith Kesner. Now, Keith is a project director at SGH, and we're going to be talking today about the intersection of project management and the field of existing structures. Now, that's going to be including the challenges, the trends, and the future directions of repair and rehabilitation practices within the next 5 to 10 years. And with that, let's jump right into today's episode. All right, everyone, it's time for our PM Conversation of the Week with Keith Kesner. Keith, welcome to the Engineering Project Management Podcast. How are you doing?
Doing well, thanks, Matt. It's a pleasure to be here.
Awesome. So let's get right into it. So I wanted to ask you about your insights on your daily responsibilities and how project management, plays a role in your work that you do today. Like, what do you do? Let's tell the viewers who Keith Kesner actually is and what you do in your profession.
Okay, so I'm a project director at Simpson Gumpertz Heger, SGH, and I joined SGH back in March of this year, and I've been involved with existing structures, predominantly working in repair and rehabilitation of existing structures for, I'm going to say, about 30 years now, with some time spent in grad school. And my current title is project director, and in that position, I'm pretty much doing everything on a project, from client and business development to working on field investigations, plans and specifications, quality reviews on projects, and seeing work through construction. So, project management and, kind of the area of project management touches on just about all that I do, every sort of aspect of what I'm involved with. And it's kind of one of the nice things about SGH that we kind of have, it's a around 700 person firm, but we're all working in much smaller groups. I'm associated with the New York office of SGH, but I'm also working to develop projects in the Philadelphia area. And as I said, we're kind of working in much smaller groups, but on a weekly basis, we're kind of bringing things together and, trying to make sure that everybody inside of our larger group is busy, trying to manage staff development. And then obviously on, the client side of project management, we're working to actively develop new clients and then keep the existing clients that we have happy. And, a lot of that involves reaching out as much as we can, learning as much as we can about the clients and understanding their needs and making sure that our project solutions are responsive to those needs. And then on the other kind of side of it is sort of the internal project, the internal project management, the staff development. As much as we can with younger staff or all staff, we want to get them a diverse experience on different types of projects. Our group in New York, we do new design, we have parking structural evaluations, we have repair projects. And with our internally in New York, we're trying to make sure that everybody's getting a diverse experience in their first couple of years, which, maybe from a pure management perspective makes things a little bit more complicated, because we're, instead of just putting one person in an area and letting them stay there, we want to keep things moving. But ideally, we're trying to get a staff that's, trained in different areas and over time can really figure out where they want to specialize. So that's a little bit of what I'm doing on a day-to-day basis from a project management perspective.
No, that's awesome.
Thank you.
No, that's awesome. So how did you get your background in there? How did you get to that point where now you have 30 years of experience working with existing structures?
Somehow it's one of those things that kind of look back and I say, well, where'd the time go? It really kind of flew by. It's interesting. And that's a good question, because when I was, as an undergraduate, I was working for a custom home builder in Fairfield County, Connecticut, and taking courses in civil engineering. And I really, at that point, as an undergraduate, you'd think I really wanted to go into that, heavy construction. That looked like a cool area. And unfortunately, going into winter break of my senior year, I called the guy up. I said, "Do you have any work for me over December, January?" And he said, "No." So I kind of didn't have a job over in that break. But luckily, one of my I was taking a final exam, and the professor said, "If anybody's interested in an internship, call this guy. He's in South Norwalk," which wasn't far from where I was living at the time. So I called him up, and he was an engineer, and is an engineering firm that specialized really in the area of existing structures and non-destructive testing, corrosion evaluations. And it's kind of been 30 years since then. It's just been an interesting,
Hmm.
diverse group of projects, a lot of different types of things. And it's really, sort of the range of products that you get into is really what's kept it interesting over the years. And from some contacts with that firm was how I first met my master's advisor at Cornell, Dr. Mary Sansaloni, and ended up with the opportunity to go to Cornell for graduate school, which was great. But it really was just kind of a random thing where I didn't have a job, so I took a phone call, made a phone call to somebody else, and it's been a great ride since then. I'm just not sure where the time's gone.
Yeah, I can definitely understand that. I kind of often wonder myself where the time has gone in my own career. Just the many changes that have happened. I also liked what you said about getting an internship, and I definitely was on that same
Hmm.
track in my career as well. I started off with internships with, some Fortune 500 company, civil engineering firms, some much smaller ones at the same exact time. So just getting that vast amount of experience, I think that internships are just one of the best ways that we can actually get into the field. And on top of that, you kind of have to have that in this day and age. I mean, now there's just so many different opportunities for internships in general for engineering students to really take advantage of, getting ahead of the game in your career. And another thing I believe to be true is that, even though you have an internship as an engineering student, it doesn't necessarily set your concrete path. It doesn't mean that you're going to stay within that one path. It's just
Yep.
really about getting the experience, getting your name out there, developing your LinkedIn profile, or, whatever your professional experience is going to be and whatever that's going to encompass. And, just getting a head start. I mean, a step forward is just a step in the right direction, right?
Yeah, and I think that's a great, you mentioned something really interesting there. You said you went to work with Fortune 500 firms,
Hmm.
larger engineering firms, smaller engineering firms. And I think that's one of the
Hmm.
great things that people don't quite understand maybe about an engineering education. Ideally, in an engineering education, you're learning how to think about things and solve problems. And that mindset where you're learning the science and you're learning how things work, but you're also learning how to specifically approach a problem and develop solutions to problems, because that's really what engineering is all about. It's applying the
Hmm.
science. But that
Right.
mindset goes into so many different things where, teaching a course at Cornell after I finished up my PhD, and this is a graduate course in structural design, and one of the students, he came up and says, you know, I'm not sure I want to be a structural designer. And I told him at the time, I said, look, one of the things you have to realize is this field that we're in, it's so diverse. There's real estate aspects of it.
Right.
There's obviously purely project management, purely construction management. And then, you talk about a lot, you hear a lot about this, and, it's not the path that I chose. A lot of engineering students, because of the math background that they have, are able to go to work for finance companies. And again, it's applying the
Yeah.
techniques, the mathematical and the physical techniques that they've learned about to solve different types of problems. So if you think about it, it's really a very diverse training that we get especially as civil engineers, because I think civil engineers more than some of the other people, we're sort of more the people persons as engineers. And there's so many areas
Yeah.
that you can go into with, a background in engineering.
Yeah. I agree with that a lot. Yeah.
No,
I'm
no,
sorry. Go
and
ahead.
I
I'm
think
sorry.
the internships are a great way to get exposed to it in different companies.
Absolutely. I mean, like, there are internships, conferences, meetings, and things that you need to really get a grasp of before you get into
Hmm.
the field because now more than ever, I think like the trajectory of most people, well, not most people, but maybe half of the people that get into the engineering field, half of them are probably going to end up aspiring to be or becoming a project manager. And client relationships is a major component of that. I mean, if you don't have that, then you're just not going to be a successful project manager, period. Right? Stakeholder management, resource management, and just knowing how to communicate and talk to people in general, I think are just major components of that. And you really get exposed to that industry a lot quicker when you take advantage of those extra curricular opportunities, such as internships, like you've mentioned before. So I know that we've kind of veered off of the point here, just having that interesting conversation there, but let's revert back. And I want to ask you about, project management in general, right? So from a project management perspective, what are some of the common drivers for undertaking repairs and rehabilitation in existing structures?
Okay, phrasing it as a project management perspective is a little bit kind of different than I typically think about the problem. But I think the biggest
Mm,
driver for all of these things is maybe not project, but program management. Let's widen that out a little bit.
mm,
So think about it as trying to avoid interruptions to the use of facilities, ensuring smooth operations. And let's just take a kind of a simple structure. It's a parking garage that's adjacent to a commercial building. There's a couple aspects to it. Obviously, from a legal point of view, the owner has to maintain it in a safe condition. That's fine. We all know that. But if you start to see spalling on the surface, you start to see damage to the joints, leaking, things like that. There's two things that really happen. The
mhm,
facility, you start to get the negative impression of the facility from a user perspective,
mhm.
and there's a
Right.
recognition that from an owner, if I fix this problem in a timely manner, and maybe it's more of a maintenance problem, it doesn't ever become a facility shutdown. So it's, from a program management perspective, it's keeping that the squeaky wheel well greased, so we don't have a problem. It's keeping the structure in operation, and maybe we're doing limited shutdown to do repairs, versus a complete
Mhm,
shutdown for a more extensive repair or a rebuild type project. The other project management or program management, there's a lot of things now that are starting, and I think it's gonna change in recent years. A lot more things are being, we'll call it ordinance driven. Um, New York City has a parking structure inspection ordinance, a facade inspection ordinance. Other facilities have
mm.
facade and inspection ordinances. So satisfying those requirements, again, it's maybe not project management, but program management requirements are some of the main drivers for undertaking repairs and rehabilitation projects.
Yeah, I think I can agree with that as well. In all of our projects, we can definitely see them as programs sometimes, like unless it's just something that's just a, super small project. But on those larger scale projects that you're talking about here, there are so many different components, as you've also stated. I mean, like the legal side, which I definitely agree with. I'm pretty sure that the ordinances and the legalities of those situations that you're dealing with can probably take some time. um, of course, there's also the stakeholder management portion, which we've already, mentioned as well. But then also the repair side, and getting with the contractors to do the work, the inspections. I definitely agree that it's more so of a program, and as opposed to just being a simple and small project. So
Well,
let's talk
the
about
other
the
part of it is obviously
yeah.
taking the time for the finances. If you're obviously a
Hmm.
stakeholder, nothing's cheap, but closing the structure down, if it's short term, long term, there are significant financial implications on that, depending upon the type of structure and the type of work that needs to be done. So that's another piece of
Hmm.
the puzzle that needs to get worked in there and balanced by both the design team and the stakeholders.
Awesome. So let's talk about the changes that you've seen. So, what changes have you seen in your career with existing structures? And I might have a little bit to add into this with my own background as well. So I'll let you go ahead, and I'll probably say what I can see as
Mhm.
changes as well.
And I think the big change that we're seeing is the recognition that, and you're seeing it in multiple professional organizations, that existing structures really are in a unique area. Obviously, every structure, we're going to say it gets built in accordance with building code requirements at the time of construction. But all of those building code
Hmm.
requirements, whether it's fire, egress, life safety codes. All those things are changing over time. And now they're ideally being improved with each version, but then we have all these existing structures that are both aging and then they weren't built to the latest, greatest building code. And there's no general requirement. Obviously, it's cost prohibitive. It's not needed for those to be changed, but we do recognize that those existing structures need to be treated in a unique manner. And there's a lot of structures that we're going to call them historic, and that's another term. What's really a historic structure? Those are treated differently than an existing structure. So I think that change that I'm seeing is that we're thinking about these existing structures as unique and development of specific requirements related to those types of structures as to when they may need to be repaired, the types of repairs that need to be completed. And that's been a big change. For a lot of years, ACI is really, as American Concrete Institute, is really focused on ACI 318 as their primary document for designing new structures. But now, in recent years, we've developed a lot of documents at the codes and standards level for specifically geared towards existing structures and some of those areas. So I think that's been a major change over the last 30 years.
Yeah, and to add on to that, I think another major change that's going to be happening in the very, very near future is the implementation of AI technology into your
Sure.
field. I can say for certain, my background was in public works, and with that, we were just now starting to see the shift into getting to some AI technologies in the realm of asset management, which is kind of in a way something that you're getting yourself into,
Yes.
right? Like we can think about something that you are managing, like you're managing a parking garage, for example, right? Let's go back to that example. That's an asset, and the asset or the people that it serves are the people that are parking in the garage, right? And there's a certain value that's attached to that. What happens is now, like the artificial intelligence space is now starting to infiltrate into the civil engineering space, and we're starting to see that there are new methods of surveying that are coming out now. There are new methods of determining uh, the damage that could be happening in a garage, like for like a particular spall, right? I remember that we were actually implementing like new roadway surveying technologies with the previous city that I was working with, and with that, we actually had like these vehicles that were driven by man, of course, but the machinery that was used inside of it was actually using some AI technology to be able to measure how big a spall actually was, how large a crack actually was, like, seeing and estimating from there with that damage that you see on the top, how far that crack could actually have ventured into the subsurface. And it's so interesting because with that, you get estimates. You can actually project and see how much it's going
Right.
to cost, when it's supposed to be repaired in the future. And you can come up with an asset management plan so you can plan for future financial planning. I think it's just so interesting how that is coming into our space now. And I'm pretty sure that that's going to be touching all industries
That's
very,
going to
very
be
soon.
that's a tremendous change that's going to be happening. It's happening now, and you're right. We're really
Mhm.
on the edge of seeing it, and there's so many things that you can do. It's really is. It's big data. When we're able to survey a structure, maybe we're going to survey it. Maybe we're going to determine the exact position of the existing structure using a LiDAR survey. And then maybe we use a drone
Mhm.
to try and access some areas that we can't physically climb into or it'd be very difficult to access. And there's a couple things that you can do with that. You can use that drone, identify certain aspects, locations where you really, really want to get your hands on it. You can use the drone for that. And then that
Mhm.
allows you to get much more focused on your investigation. So you can get into that area where you're seeing from a drone some type of damage. Alternately, once you have that data, you can start to think about ways in which you can start to say, okay, I have this crack. I can physically measure something like a chloride content, a salt content inside of the concrete. And I can do some other measurements where maybe I can find out that reinforcing steel is actively corroding. Well, that starts to give you the potential to start predicting what's going to happen. And as you said, where that fall is going to be in a couple of years or how it may progress and what's the impact on eventually the capacity of the structure. And it's really that sort of that service life and big data and the ability to use that is going to be really advance the profession. I recently completed a project at a university's football stadium. And one of the things that was done in that project is we embedded a lot of corrosion sensors plus some relative humidity and temperature sensors inside the repaired structure. And we're using that data, and we'll use that data to predict when the coating system may wear out and how our corrosion protection system is working. So really that ability to both plan for and capture and then use big data is really going to change the way, ideally it'll improve the way we manage these assets and allow for much greater use of resources.
Yeah, I think that'll be a major shift. Very important, very needed. I think that it will make our jobs on both sides easier and
Easier,
harder
harder, but
at the same exact time.
easier and harder, but it's also
But
more
efficient.
efficient. But let's be honest, some of the stuff's just plain fun. I mean, it's really we're
Yeah.
looking at things that
Yeah.
we've never been able to, we couldn't have done 20 years ago, and
Yeah.
we're taking out some of the. I mean, there's going out and field measuring a structure by hand, boring. It's
Oh
boring.
no.
It's boring. I mean, we're
Yeah.
making we're bringing all the technology we can to these problems, and we're making it more fun. So I think that's great.
Yeah, and also eliminating the possibility of human error. Now, obviously, there are going to be some that happen along the way, but if you can reduce it down 1 to 2%, that's a major difference in thousands or hundreds of thousands of dollars on certain
Yep.
repairs.
We always talk about sustainability. We hear a lot about sustainability.
Right.
Keeping existing structures in good service is sustainability. And by not having to take structures out of service, not having to tear them down, that's doing a lot
Hmm.
to preserve resources. And this is just giving us new tools to do
Absolutely.
it.
Veering back, you had said something about
Yeah.
ACI, and that's the American Concrete Institute, right? So I know that there are some new documents that are coming out on the ACI side. So how do you think that that's going to affect the way that your projects are managed in this field?
So a lot of the new documents, and I've been involved with development of several of them, they're focused on different aspects of existing structures. And ideally, what we're doing is all these changes. We're trying to improve engineering practice, improving the safety, expected durability of existing structures. Um, I'm not sure how they're going to change the management of existing of projects, but the one thing I think they will do was provide a little bit more flexibility to design professionals in terms of how we can approach existing projects to allow us to use some different materials, a lot of things like FRP materials, glass fiber bars. All of those will have greater use now that they've been developed, and the codes are being developed specifically for using in them. So that allows us to change how we
Hmm.
can design both new structures and repair. But I think one of the more bigger ones that I think is changing is maybe there's starting to see a lot more interest in a design build approach to some projects on existing structures compared to a traditional design
Hmm.
build. And I think that may be in the next 10 years, I think that may be a bigger change than maybe some of the ACI codes and standards in terms of how things are managed, not in terms of how the projects are executed, but specifically how they're managed. So I'm not sure I answered your question with respect to project management, but hopefully provided a little bit of insight as to where I think it's going.
Yeah, no, like you definitely did touch on it, but it actually raised another question for me about like where you see your industry going within like the next 5 to 10 years. And I mean, we kind of talked about it a little bit, but um, could you peer a little bit more into that? Like, where do you see this practice of repair and rehabilitation going in the next 10 years? And what do you think are the main challenges that you're going to experience with that change?
So that's a good question. So in the next 5 to 10 years, I think we will see more design build type repair project. I think that's a trend that's occurring in the industry. And there's obviously some
Hmm.
project management risk associated with that we're going to need to work out from a contracts point of view, from a owner risk point of view, just because of the amount of uncertainty that we have in existing structures. And then, so 5 to 10 years in the area of existing structures, we have a lot of existing structures. And just like me, I'm getting old. They're getting old too. And I think Surfside was a real wake up call to that something terrible could possibly happen to an existing structure that I didn't think a lot of people were thinking about. We have a lot of structures in a coastal environment that have been exposed to significant coastal environment. So that's chlorides, high temperatures, potentially a very corrosive environment for a long time. Some of those structures are in poor condition, and I think we need to really step back and think about how we're surveying those assets and understanding what's going on with the condition of those structures. A lot of those structures were obviously built with older building codes. They may not have all of the features of a modern building code with respect to crack control, resistance to progressive failures. So those are things that we need to think about and understand how those structures are going to perform as they get older and continue to age, and what sort of strategies maybe have. And then we're going to continue to see, like we just talked about, all of these new technologies. They're going to give us a greater ability to look at these older structures and ideally figure out ways to keep them in service. So those are some of the challenges. And then the other thing we need to do with that is make sure, as we talked about earlier, ordinances with respect to existing structures. We need to continue to work on the development. I think those are very important in terms of forcing engineers and forcing owners to look at their structure in a critical manner and make decisions about how they are being managed. And then ideally from the project management, the program management, whatever we want to call it, start to think about how we can maintain and financially plan for the repairs or maintenance that's going to be required to keep these things in service.
So we talked a little bit about the challenges. Now let's talk about what excites you and what you're looking forward to. You know, what excites you about this field of structural engineering?
I think there's a couple things that have always been super interesting. It's you go out and you get the opportunity to look at, so you get the opportunity to really look at history. You think about a structure, and I'm going to mention one that I worked on, which was Franklin Field. It's about 100 years old right now, the main structure. In 1932, Franklin Roosevelt, he accepted the Democratic nomination for presidency at Franklin Field. So you think back, it's not the same field, but you're out there in the structure. That's where he was. So that's kind of cool. You look back, you're working on a structure where actual history occurred, and you're trying to keep it in service. You're trying to figure out what went on. You look at different things every day when you're thinking about existing structures. You see something that you haven't seen before. It's a new structural system. It's a different damage mechanism or a different way that some other engineer detailed something, and you look at it and you say, wow, that was really, really clever, or oh man, that didn't work at all. And it's that kind of opportunity to look at something, study it for a while, and then step back and say, okay, we could make this better. We can recognize that this is really cool, and it worked. Or we can say, okay, this is bad enough that I think, well, we can really got to step back and think about maybe what kind of code changes are necessary to address this condition. So it's all of those areas. And I guess the other piece about it, I've been super blessed over the last 30 years to work with some really cool people. I've had some great mentors in this area. I'll name Randy Poston, Dan McCarthy, a couple really good engineers, some well-known guys at ACI, Larry Kahn. It's just the opportunity to work with some really nice people, and I've had some great, and still do have really great coworkers that I have a lot of fun working with. And at the end of the day, a lot of the stuff we do, it's very much, it's technical, but it is about people. And if you find a group of people that you like working with, it makes everything you're doing much more fun. So I think that's kind of the stuff that excites me about structural engineering. Maybe I'm not excited about structural engineering so much as existing, structures and, working with people. Um, but you gotta have find things that are fun with your job.
Oh, absolutely. I mean, I think that delves into the passion portion of our professions. I mean, I always say if you're not passionate about it, you're just going to drag your knuckles,
Hmm.
along, with your work, and that has a intrinsic effect on how your work gets done, how your project gets executed, how your team structure is going to be,
Sure.
your team's morale. I mean, I think that if I can chime in, one thing I'm really excited about, with not even just structural engineering, but engineering in general, is I'm excited when I see the past methods of best management practices. I'm excited when I see, okay, like this is what we did back in, like you were saying, like the 30s or the 40s or the 50s. And this is like the technology that we had at this point in time. And this is how this implementation of this technology affects us now in 2022 or 2023, whatever the year may be. And we are seeing now that did not work. There's now something that's better. And that's something that really interests me a lot with the repair and rehabilitation aspect of engineering. Like I don't think that there's a ton of people that are really interested or in our field specifically, but it's so interesting to me because, I like to take something that is broken down, something
Hmm.
from nothing, and then turn it into something,
Sure.
right? Um, I just love to see like how new technology gets implemented. Like even back when I was working, doing public works, it was just very interesting to see like, okay, well, this is the type of storm pipe that we used to use. This was the standard at this point in time. And this is the limits of what our human brains could even fathom at this point. But now we're seeing that this is not actually good, like i.e. using lead piping. And now we're starting to see, or lead or
Yeah.
asbestos piping. And now we're seeing that that's something that's not good. So now we have to repair it. And then there's just a huge downfall that comes with that, the asset management planning, the project management that comes with that, the cost management, just coming up with a whole entire plan to really
Yeah.
revolutionize your whole entire city's infrastructure. That really fascinates me a lot.
And yeah, those are some really those are you touch on some of the really big questions as to, you know how do you make and go about major changes in a you're talking about a city infrastructure, whether it's critical infrastructure, how do you do it while keeping it in service? And that's really like so
Right.
many of these
That's very
so many of
interesting.
these bigger projects that we have. The cost isn't the actual materials, it's not the engineering, it's this amount of time engineering it to keeping it in service. I was just reading something. Amtrak is planning on retrofitting a couple of bridges in the state of Connecticut, and they're up on two projects. They're on $1 billion budgets, $1 billion+ budgets planned out.
Mm,
And that's not,
wow.
they're old. I mean, they're 100-year-old lifespan bridges that need to be replaced, but it's rail track. What can't you easily jog around like you can with a car, a train? So you got to keep that bridge in service while you're replacing it with something new. And that's really complicated and that's really challenging. And there's a lot of limitations to all that. Um, and those are some of the toughest projects that you're going to get. And to some extent, they're also some of the hardest projects because no matter what, it's not so much on a rail project, but if you're thinking about this on a roadway, nobody wants to be in a traffic jam. No, because of
Yeah.
repair construction. That's and the I think from a public planning perspective, a politician wants to be there at the ribbon cutting for the brand new structure, but they're not necessarily planning to show up
Hmm.
at the start of a 5-year traffic jam. That's kind of a different
Right.
world. But those are the things that we really need to focus on to keep all this stuff in good service and keep things safe.
No, I agree with that wholeheartedly. So, as we start to wrap up this conversation here, we're wrapping up the meat of the conversation. I just wanted to ask, like, if there's any final piece of advice that you would give to engineers that are involved in repair and rehabilitation projects, like, what advice would you give them? either if they're just starting their career or if they're already in the career right now, and well versed, maybe 10 years of experience or so, what advice would you give them on either how to start or how to maintain and how to grow?
I think there's a couple of things I would advise a younger engineer, a younger version of myself. One is to find some really good mentors and some, whether it's
Mm.
in your field or associated with your field. I've been lucky. I mentioned Randy Poston, but, Sarah Billington, Mary Stanceloni, my graduate school advisors, Ken Hober, those were all people that, if I had a question or, uncertain about something, I could always feel like I could reach out to them and they'd be able to help me. And that's been super helpful. Some of the things like some of the different professional organizations like ACI, ICRI, ASCE, they're all super helpful for people as just as a source of where you can learn more stuff. And you can, get involved and develop that, sort of professional network so that, when you come across problems, you can kind of have some other people to reach out to that are, that are your peers, and see, kind of get a perspective as what's going on in different aspects of the industry or different parts of the country. And, a network of, if I'm a design professional, I can reach out to some people that I know that are contractors at ACI in different parts of the country if projects come up and say, oh, do you know somebody that can do this? And that's, I've always found to be very helpful. Plus, really focused, we as engineers, a lot of states are requiring PDH credits, but that's that sort of commitment to figuring out a way to keep learning stuff. When I was giving a seminar a couple of years back at University of Connecticut, and somebody asked me a question about how what I learned in school is being used in my day-to-day profession, and I kind of thought about it for a second. And it's kind of a 90-10 rule. It was what I came up with, and I said, on any given day, you may have to use 10% of what you learned in school, but you never know which 10% that's going to be. And at some point,
Right.
you're going to be using all of that stuff that you learned in school, but you don't know what you're going to need to have on some day. And then, so, the other half of that is there's an awful lot of stuff that you got to learn on the job. So you got to figure out a way to keep learning stuff.
Yeah, I agree with that. And major thing that stuck out for me, like just came to my mind, is just working out your engineering muscle.
Mm-hmm.
Um, and what I consider that to be is like, you have to train yourself outside of your job, outside of your workplace. And I mean, it's, as you said, networking is extremely important because you learn so much from going to those ASCE meetings and conferences. So, get involved with the young members group, get involved with just the state or the state or city branch or chapter that
Sure.
you have local to you, in order for you to really learn, network, and getting to know different people, asking the hard questions that you need to ask. So no, I really appreciate that information that you've given. um, so we're going to take a quick break here, and when we get back, we're going to be talking to Keith about the PM pitfall segment and what he sees as one of the biggest PM pitfalls in his industry right now. Stay tuned. All right, everyone, we are back with the Engineering Project Management Podcast, and we have Keith Kesner here. Right now, we're going to be going into our PM Pitfalls segment. So, Keith, we wanted to ask you, what is the largest PM pitfall that you see in your industry right now, and how do you advise for project managers or aspiring project managers to get through those PM pitfalls?
Okay. It's an interesting question. And my answer is really not taking the time to really understand what your client wants from a project. And when we're working on existing structures, especially repair projects, there's a lot of options available. All of those options, different costs, different service lives. And I think it takes a lot of effort, and your client may not know this, may not know the answer to this question, but what is your client really looking for on the project, and what sort of like expected service life one are they thinking about? And let me kind of give you an example. I was 20 plus years ago, I was working on a project. We were finishing a parking structure repair project, and it was very invasive, a lot of night work. And at the end, we recognized we wanted to do something, some sort of a coating, membrane type coating on it. And the owner, he said to us, "Well, how long do you think that's going to last?" And we said, "Well, I think it's going to have, well, we'll get a 5-year warranty." And that was pretty standard. And basically, the owner, he told us pretty much that was not a 5-year warranty where maybe you're going to be back in 5 years wasn't that good. That's not what he wanted. He did not want to see something. He wanted something with a longer service life. And he was, he said, I could have gotten a 5-year warranty and had any engineer come up with that. I wanted something, I wanted you guys involved because I wanted something, more thought through, something with a longer service life. So we had to go back and really go back to our drawing boards and come up with a different solution. And I think we could have, it caused some problems at the time, but if we had thought about it a little bit more and really worked in and understood it, what he was looking for, and the fact that he wanted a much longer service life project, repair program and a final capstone on it, that would have saved us a lot of heartache. So I think the pitfall is, when you get into these projects where there are a lot of options, figure out exactly what your client is looking for, or really take the effort to explain the implications of all these options are, and that's really going to help get the most value for your client. And that's really, at the end of the day, what we really need to do is get our clients the best value. So I hope that is, hope that's something that people, when they think about, can try and avoid in the future, and not have some unsatisfied clients at the end of a job.
No, absolutely. I think that's really the biggest outcome that we want, right? At the end of our projects, we want our client to be satisfied, right? We want them to not only be satisfied, but to keep on coming back
Sure.
for more. We want to continuously keep on feeding a pipeline of projects that are coming now and in the future to keep our businesses thriving. So I really appreciate that advice, and I appreciate you coming on to the podcast today. Thank you for sharing some information with us about repair and rehabilitation. It's something that we really haven't dived into too much on this channel, but I'm glad that now we have that perspective of how that is done. Not just from not just from my side, not just from the local
Mm-hmm.
municipality side, but also on the commercial and residential side, as you've stated, on some bigger projects. So we really appreciate you coming on to the podcast today.
Well,
Thank
thanks,
you.
Matt. Thanks for having me. It's been fun.
Please remember that you can find the show notes for this episode at www.engineeringpmpodcast.com. And there you'll find a summary of the key points that we discussed in today's episode, as well as links to any of the resources, the websites, or the books that we mentioned in today's episode as well. Until next time, I wish you all the very, very best in your project management endeavors. Take care.